Let's make better delay functions with the hardware timer. The timer and counter is a peripheral built into the 8051 used to time events, create delays, generate baud rates, as well as count external events. The 8051 has two independent timers, timer 0 and timer 1, which are 16-bit wide. Before a timer will function, it needs a clock input. For a standard 8051 microcontroller, which is a 12-clock architecture, it takes 12 clock cycles to have a one-machine cycle. Thus, if we have a crystal frequency of 11.0592 MHz, we divide it by 12, resulting to 921.6 kHz, and it becomes the input clock to the timer. For this clock frequency, we have 1.085 microseconds input to our 16-bit timer. The 8051 has two timers, timer 0 and timer 1. These timers are both 16-bit wide. Since we have an 8-bit architecture, each of these timers are accessed by two separate 8-bit registers, TH0 and TL0 for timer 0, and TH1 and TL1 for timer 1. The 8051 also has a timer mode register, called the TMOD register. It is an 8-bit register, used to set timer modes of timer 0 and timer 1. The lower nibble are for timer 0, and the upper nibble are for timer 1 as shown. In addition to the TMOD register, we have the TCON register, which is an 8-bit control register which contains flags for the timer and interrupts. For example, we want to create a 1 millisecond delay using timer 0, mode 1, 16-bit timer mode. In order to do this, we have to do some calculations. First, we divide our desired time by our input clock. In our case, we divide 1 millisecond by 1.085 microseconds, giving us roughly 922. Next, we subtract 922 to the maximum count of the timer. In our case, in 16-bit mode, we have 65,536. Subtract 922 will give us 64,614. Then, we convert it to hexadecimal. We load FC to TH0 and 66 to TL0. We create a subroutine for our timer 0. First, we set timer 0 to mode 1 through the TMOD register, then we load the initial values to TH0 and TL0. Next, start the timer by setting TR0, then wait until overflow, then we stop the timer and clear the flag. Now we have our routine for our hardware delay timer. We load our program to our development board, and as we can see from the oscilloscope, we have a perfect 1 millisecond square wave. Using for loops, we can have an extended delay by calling our hardware delay subroutine several times. As we can see, we have blink rate of 100 milliseconds. I hope you learned something. Don't forget to hit like and subscribe. Until next.